Hello, good evening. Hello, good evening, all of you. Today we are going to do the last part of this chapter. Not last part of this chapter. Final revision. So as I promised you, tonight we are going to do a bit of revision on this hit. Okay, and then after this, you got any question want to ask me? Please send it to me or send it to the Telegram group or WhatsApp group, and I will answer you. Okay, so we just start from hit first. Okay, now I want to repeat for one more time. So the essay question that I am predicting, it is heat, and then pressure, and then one more, it is electromagnet. So because of the limited time, so I don't discuss with you the electromagnet. So you have to go on your own. But today, final already. So tonight, probably you need to study until 12 if you want. Okay, now let's go. All right. Heat. You need to know sometime if they come out in the structural question, they will ask you what is heat. Heat, it is the energy contained in the object. Heat, it is not degree of hotness, but temperature, it is degree of hotness. You need to know how to differentiate them. Okay, heat, it is a kind of energy. So 4.1, you need to know what is thermal equilibrium. The keyword for the thermal equilibrium is net heat flow equal to 0. Net heat flow between two objects is equal to 0. Alright, this one is the one that you must write. And during the thermal equilibrium, so temperature of the two objects must be the same. Alright, so when one it is hot, one it is cold, right? When you put them together, we call it as we got a thermal contact. So the heat will flow from hot to cold and cold to hot also. But the rate mean how fast it is. The rate of the heat flow from the hot to cold, it is fast. Flow fast. Right? So the heat flow from the cold to hot, it is slow. So until they are reaching the same temperature. Right? When they reach the same temperature, we call it as thermal equilibrium. Right? So thermal equilibrium. And then a common mistake that the student make is, now the student said when thermal equilibrium there is no net heat flow. Yeah, this is correct. But if you said no heat flow between two objects, salah. This one is salah. No heat flow, salah. No net heat flow, because the heat still flow to here from A to B, and from the heat flow from A to B and B to A, it is the same. Right? You need to know. So basically, you need to know what is the application of the thermal equilibrium in daily life. For example, the oven. All right. So the cake that you bake, so the heat flow into the cake, it is fast. The heat flow out, it is slow until both are getting hot. Right. So thermal equilibrium achieved. So the cake can be baked. Or the thermometer. So the thermometer heat flow from the body to the thermometer, and then the heat flow from the thermometer to the body. So because of your body, it is hot. So heat flow from the body to the temperature, it is fast. Right? The rate is high. And the thermometer flow back to the body, it is slow. So until thermal equilibrium is achieved, the body's temperature same as the clinical thermometer. All right. icebox, saucer, coaster, same. All right, all of these are this one is the use of the thermal equilibrium. Wait yeah. All right. You can try to go and have a read. Go to read. Okay. Now, first thing, the second one. Okay. Now, the second thing is how to calibrate the liquid in glass thermometer by using two fixed points. So, this one, it is important, even it is in essay, structural, or calculation. For the essay part at the back there, it is important, so you need to know. Now, when they ask why mercury is used as the liquid in thermometer, you need to know how to answer. So this is all the answer here. Right, this is all the answer. Right, expand uniformly when heated. Right, good heat conductor. Don't write good conductor. Good conductor salah. Right, need to write good heat conductor. Opaque, low freezing point, and high boiling point. Right. Okay. Now, the alcohol is used in the clinical thermometer because it is not harmful to the body, right? If even it is leak. So, and then the size of the bulb, it is small, have to be small. Why? So it will contain less of mercury, absorb more heat faster, right? Absorb more heat and more quickly. So this one, the capillary tube. Where is the capillary tube here? Inside here. The red one, can you see it? So this one have to be narrow, have to be small. Okay? So that it will be more sensitive. And then the glass wall must be thin. The glass wall of the bulb here it is thin. This part it is thin. Why it is thin? It can absorb more heat faster. But the glass wall of the stem here, it is thick. So the heat will not escape easily. So the heat will not lost to surrounding easily. Okay. Now, of course, you ask me, Jegu, how about this one thin? If this one thick, then cannot absorb heat? No. Why? Absorb heat we are using here. We don't absorb heat from here. Thermometer, you put in your mouth here. Not here. This part not put into the mouth. No. Okay? You need to know. So the part that absorb heat, it is from the bulb. Okay. The stem, it is long. Why have to be long? You can have more reading, wider range of reading. High boiling point, not evaporate easily. Low freezing point, not turn to solid easily. Okay. Now, of course, this one inside the clinical thermometer, we are using alcohol. So because of it is not harmful to the body, and then the boiling point of the alcohol, it is low, yeah, but it is at least 70 something, 60 something, 70 something. So your body temperature will not reach that temperature. Reach that temperature mean you are GG already. So 42 high fever already, 40 high fever already. So you cannot reach 60 something. 60 something, virus also die. Bacteria also die. Okay. So this one you need to know how to use the formula. All right, I will take one example only. So theta is equals to L theta minus L theta minus L0 L naught over L100 minus L naught L0 times 100 degrees Celsius. Right, you need to know how to use this formula. Right, this formula, it is not given, so you need to by heart it. All right, you need to memorize it. Okay, if you can, you go and memorize it. It is not given. Okay, now for example, I take one example. Let's say this one. Okay, I just take this one, number 2, example number 2. So now when the thermometer is immersed in boiling point means 100 degrees Celsius. So the length it is 35.6. And then immersed in the ice cube means 0. Right? So it is 2.3. So now L theta, length when theta, length if you immerse in a 25, okay, 25. Length when theta, you don't know, L theta. Minus length when 0, it is 2.3. Over length when 100, it is 35.6. Minus 2.3 times 100. Okay, so you get this. You cross and play with your mathematics. Then you get the answer. Okay, make sure you know how to do. Right, this one, if calculation come out, so it will be, normally it is 2 part, part 1 and part 2. So you need to be careful. So this one normally will be 3 mark, 2 to 3 mark. Okay. Others, I don't think it is important, so I will skip. Now, make sure you know, set the physical. This one, you need to know, and this one, So now, sometimes they'll ask you, set the reason for choosing the mercury. In why are you using mercury? Okay, you need to always use this one. This one is the best one. Expand uniformly when heated. Okay? Expand uniformly when heated. Alright. So, other will be okay. So, you need to know how to do this kind of question. Alright. Just now, I have discussed it already. Okay? So, this one, you need to know how to answer. Okay, so the more important part, it is latent heat and heat capacity both. So we are going to go to here, 4.2, heat capacity. So what is heat capacity? Q is equals to mc theta. So Q, I want to find C, right? I want to know what is C. So M have to go down. Theta have to go down. So C is equal to Q over M and theta. Q is energy. Alright, energy. Alright, quantity of heat or quantity of energy. Heat is a kind of energy. Quantity of energy needed to rest. Or I want you to write to change. It is better. Because of it can be go up or go down. It can be go up into this way, heat capacity. It can be go down this way. Right? Heat capacity here. So I don't want you to write to rest. If you get used to rest already, okay lah. You can set the, if you rest, you can write the quantity of heat absorbed. Right? Not I use the word of needed because of it can be absorbed or released. Right? So I prefer you to write the energy needed for an object. Because of heat capacity, we don't know how many kg. So M, you don't need to write 1 kg. Make sure you don't write 1 kg. To change the temperature by 1 degree Celsius. I repeat one more time. Energy needed to change the temperature of the object by 1 degree Celsius. Okay? But if they ask what is specific heat capacity, so you need to add in 1 kg. Energy needed to change the temperature of the object of 1 kg by 1 degree Celsius. Okay? Alright, this one, I hope you memorize it. And then, next thing. So, you need to know here, heat capacity high. It is something very hard to heat up. Heat capacity low means easy to heat up. And if hard to heat up and it will also hard to cool down. That is a characteristic of the heat capacity high. All right. For example, a cooking pot, a clay pot, so very hard to cool down. Right. Once it is heat, very hard to cool down. But if you want to make it hot, it will take time. But this is a metal pot, so metal pot easy to heat up. You cook, you use metal pot, yeah, fast to cook, right? But if you want to keep warm, so this one it is the best one, right? It can stay hot for longer period, depend on which one, right? So this one easy to cool down also. All right. So example, we try to take one question here. So now find the energy needed for 500 grams of aluminum to increase the temperature from here to here. So heat capacity is aluminum is 1000. Q is equals to mc theta. Q I don't have it. M, now 500 gram. Don't use gram, use kg. So 0.5. C, heat capacity is 1000. Theta, change in the temperature at T5, at T minus 25, at T minus 25. So you will get the answer. Answer, it is in joule, right? In joule. The unit must be in joule. Okay. Now, from here, I takut it will come out like the other way to ask you. So you need to know the energy's formula. So energy is power times time. Power is equal to VI, electrical power. For example, this kind of question, you see, this one is kilowatt power. So you need to power times time. Time must be in second. Okay. If don't have power, then they will give you voltage and current. All right. Make sure you know. Put it in. Or E is equal to mgh also can. So for this kind of question, like mgh is equal to mc theta, yeah. Okay, and then it also can be kinetic energy, right? So energy cannot be created, cannot be destroyed. Energy only can be transformed. So you can use this few formula, right? Make sure W is PT, P is VI, E is mgh, right? E is half mv squared. Sometimes they don't give you the m, as the m can be cancelled. Like for example, I take this example. A bullet with 300 velocity, 300. Bullet fired from the pistol, and then find a maximum increase in the temperature. So when it hit the object, so the object will get hot, right? So the heat will transfer to this object. This object getting hot. Let's say it embered into your body, so your body will get hot. So Q is equals to mc theta. What is a Q? Q is the energy from here. What kind of energy it is? Kinetic energy. So teacher, this question not giving M on it. Mind cancel it. Cancel it. So V, put it in. C, put it in. And then theta. You can find the theta. Alright? Huh? Is that okay? This kind of question, like I need to spend some time. This one, it can come up in the calculation. If AC come out, it can come up in the calculation at the part C or D in essay. So you need to know how to do this. So I'll go into detail, no worry. So you got a metal ball with 500 grams. Temperature 100. Heat capacity 1000. Okay, everything given. It's thrown into the water. Throw into the water. Water 300 grams. Heat capacity 4002, and then temperature of this one right now, it is 25. So hot 100-degree hot ball, hot metal ball, you throw into the cold water. So this one, the answer must be in between 25 to 100, it become warm. hot plus cold, it will become warm. So the final temperature, not this one plus this one divided by 2. No. Don't do it. So it must be in between 25 to 100. Okay. So how to do it? Now, I should write here, heat absorbed is equal to heat release. So this one is hot. So it will release some heat. It will release some heat to here, to the water. But the water will be absorbed heat. Alright. So this one is heat release. If you want to write, is equal to heat absorbed. In this question, they will ask you what is your assumption max. Now, the assumption max always no heat loss to surrounding. Because of heat release to here, heat absorbed to here, heat absorbed from here, alright, from the water. So there is no heat loss to surrounding. If heat loss to surrounding, then it will not be this temperature. Alright, so heat absorbed is heat release. MC theta is equal to MC theta. So now the most of the student they will get wrong from the theta here. Be careful. So M 0.5, C 1000. Theta is change in the temperature. Change in the temperature. Change in temperature is 100 minus theta. High, big number minus small number. Right? 100 minus theta. Okay. Now is equal to MC theta here. MC theta of water. M 0.3. C 4002. And then change in the temperature. It is theta. Theta minus 25. Not 25 minus theta. Teacher, this one you 100 minus theta. But this one theta minus 25. You have to use a bigger minus smaller one. Because this one is positive number. Right? 100 minus theta. You know theta is 46 right now, right? So theta is 46. 100 minus theta is positive. If you use 46 here minus 25, it is positive. If you use 25 minus theta, you will get negative. So positive it cannot equal to negative one. Okay, make sure you know big minus small. You know this is warmer. So big minus small. And then big minus small. Make sure you know. Okay, so you can calculate it, time it in, expand it, and then blah, 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 get the answer. Okay, now if both are water, you still need to do this. Yes, you still need to do this, but your C can be cancelled. Right, C can be cancelled. Right, if it is in objective, you can use this one. It is kind of like the at maths, right? The formula at maths to find the part of like this one middle point. When this is 2 coordinate x1 y1, this is x2 y2, and then this one. It is kind of right. So how to do this? So I'm going to teach you using this way. Now find the final temperature. So if objective, you can use this one multiplied by this one plus this one multiplied by this one divide by total mass. Okay, how to do it? So if you want to do shortcut here, so 400 gram, you can use 0.4, up to you, right? I use 400 gram times 30 plus 500 times 80 equal divide by total mass. 400 plus 500 is 900. You get the answer, 57.78. Right? If you use heat absorbed is heat release, MC theta is MC theta, M 0.4, C don't know, they don't give, right? Because this is both are water, later you can cancel. And then theta, big minus small. So 30 and 80. Here theta is must be the final temperature must be in between 30 to 80. So big minus small. The theta minus 30. But this one is 80 minus theta. 80 minus theta. So you multiply it in and then you get the answer. Alright? Now, is there any question from here? This one, make sure you know how to do. 5 marks. 5 marks. I need to tell you, this one is 5 marks in the exam. Calculation. So, this one, I don't think it is important already. Because your paper 3 done already. So, I am not going to go into detail. So, next one, it is application of the specific heat capacity. So, you need to know this one. Alright, if the question come out in 4 mark, alright, how to make the bottle boil faster? You need to know how. Okay, now, this one can come out in essay. Alright, choose the best cooking pot. For example, they give you a table like this. PQRS. So the part of here, what is this one make? The best. Alright, best. The body. Okay, and then the handle. Made of what? Wood, plastic, copper, or what? Okay, they can give you this kind of question. You need to choose one. Okay, it can come out into this way. Now, how? So now, because of you cooking pot, you are using it to cook, right? Or you are going to use to boil water, right? So now heat must be from the bottom, cannot from the side one. You impossible for you to boil the water. You use a Bunsen burner to heat here. No. The heat will go up, so it is not effective. So now this one must be easily get hot. So copper, low heat capacity, so it can heat up very, very fast. So you can boil water faster. But after heat up, this one the heat will go out, right? So you don't want it to go out. So higher heat capacity. So aluminium, and then aluminium also it is light, and then not easily get rust. Okay. Now the next one is the plastic or wooden handle here, right? This wooden handle. So it is high heat capacity or it is heat insulator. So you need to know lah. So this one, if come up, then it will give you 1, 2, 3, 4, 5, 6 mark, and then still got, you need to choose 7, 8. Still got one more, so it probably asks here, right? How to make it faster? Add in, you need to use a lid here, penutup, or cover. So increase the pressure inside, right? So that it can boil faster or reduce the heat loss to surrounding you. Cover it. All right. Okay. Now car radiator system. If can, you go and read on your own. Right. This one, I don't go into detail because of I think it will not come out already, because many times come out already. Count many times already. It's so long time ago. So this one, so you need to know lah. Never mind lah, I explain lah. If not, later come out how? All right. So here, this is the engine. This is your car. So the engine people move, right? Engine is hot here. Hot, very hot. So the hot, this water it is called. So this one is called thermal equilibrium. The heat will transfer from the hot to cold and cold to hot, but the rate go to the water, it is higher. So make the water become hot. Water become hot here. At first the water it is cold. Now water it is hot. Cold water become hot water. Alright. So the water absorb heat from the engine. You need to know. So the cold water become hot water. Why are you using water? Because water has high heat capacity. Alright. And then it can absorb a lot of heat, but not increase much in the temperature. Hard to heat up. Don't just write hard to heat up. You explain. Alright. High heat capacity. So it can absorb a lot of heat, but not increase much in the temperature. And then it is cheap, not easy, and easily You can get it from longkang water, boleh, right? Tap water, okay, no problem. All right. So of course, if you can put in some other chemical, it will be better, right? But what normal water will be okay already. So now this is hot water. Hot water, you got a pump here. It will circulate the water, hot water to the front. You move the water here to here. All right, this is hot. Just now this one is cold. Now this is hot. Now this is hot. How? What should we do? We are going to use a fan. This is called radiator fan. Radiator fan, sorry. Radiator fan. Radiator fan. Radiator fan. And then you blow the wind so the hot water will be cooled down. Right? So this one, not only this, you got a cooling fins here. Cooling fins here. Cooling fins. These cooling fins, it is going to trap the wind. The wind go in here, wind go in here, wind go in here. So it will cool down the water also. So have to be more cooling fins. And then the hot water now, just now is hot water. Now this one become cold water already here, or cold water already. Cold water start to flow to here because we got pump, right? Flow to here, flow to here. So this is cold. Then what should you do? You will repeat the same thing. Go absorb the heat, absorb the heat, absorb the heat, and then become hot. Hot, and then bring to the front, become cold. And then go to the back, become hot. Go to the front, become cold. Keep on repeating. So it can ask you, how can it ask? It can ask in this way lah. For example, it can ask in this way. So this is the cooling fins. Which one it is best one? Later, extra exercise. I want you to try to do this one again later. I will let you do. Right? Okay. Now, the production of the lattice material in the construction of green building also. This one it is. We call this one is diamond building in KL. Diamond building, so it can absorb because of they are using styrofoam, so high heat capacity for the roof there. So styrofoam is here, so the building will not get hot easily, so you don't need to turn on the aircon even in the hot day. Okay, and then this one, it might be come out. If it come out, it can come out in 4 marks one. Right, so you need to know sea breeze, how can it be happen, or land breeze. Right, this one very popular question. I don't think it will come out again. Right, so for me I don't think it will come out again. So here, but anyhow, we need to discuss a bit. So because of we know the land has low heat capacity, water high heat capacity. So this one hot, very slow. Heat up slow, right? This one hot, very fast. Heat up very fast, right? Low heat capacity, easily heat up. So now, if they ask you explain how the sea breeze work, okay? Now land heat capacity, it is low, 1 mark. Heat capacity low, 1 mark. Now you explain, you try to explain, so it can heat up easily. 2nd mark. So the hot air rising up here from the land side there. Because of hot, right? This one is cold, this one is hot. So hot air rising up. Hot air rising up. So the wind from the sea will blow to the land. So hot air rising up, 3rd mark. Right? Wind from here, 4th mark. This one rise up. Teacher, why this one rise up? The wind will blow from here. When this one rise up, mean the air particle here is less. Right? Low density. Low density mean less particle. Less number of particle. So the pressure is low. So higher pressure, it will blow to the lower pressure to fill in the blank. Okay? Now, this is sea breeze. How about land breeze? Land breeze, the same one. Same one, just terbalik. Okay, so at night still hot. No, night is cool. Alright, so land heat capacity low, yeah, heat capacity low. So because of normal heat from here, not like Afternoon, very hot. Now this one at night, cold. Cold, it cool down very slow. It cool down very fast. Heat up very fast, cool down also very fast. So this one is cold. Right? This one is cold, but the seawater has high heat capacity. It will remain very, very hot there. So this one 1 mark. You stay hot for longer period, 2 mark. So hot air rising up. This one will give you, if you feel like it is not enough mark, you write this few. Right? This one, 3rd mark. Right? These two, you try to write it. Right? So the the density of the air at the surface of the water here, it is low. So pressure, it is low. So the wind will blow from the land. So this is called land breeze. Alright, land breeze. Alright. I hope you're okay. Now, as I promised you, I give you like 10 minutes to try to do this, and then I'll give you the answer later. Right? I really hope that you can write less than 10 minutes. So now it is at 06. So I read the question and then you answer. Table 2 shows the characteristic of coolant liquid and the design of the vane radiator engine radiator. Explain the suitability of the characteristic in table 2. So choose the most suitable vane radiator to be used and justify your choice. Okay, so this is the question. This is the question. So you do it and we are going to discuss within 10 minutes. Alright, so I'll be right back. Do it. All right, have you done it? Okay, so we quickly go for the answer. So this one, okay, let me explain first. Okay, so normally I will do from the left to the right. Okay, so cooling fins, right? You see the cooling fins, here. This one it is quite little. This one is quite density is quite high, so quite a lot. So this one is good. This one is good. This one is good. This one is good. Okay, so this one out. So fan, the fan here it is big. This one is small. This one is small. Out. This one out. I mean the cooling fins out. So this one okay. This one okay. This one out. This one okay. So this one okay. Okay. Left J and L. Now we look at the low corroding rate and then heat capacity. Heat capacity is 5,000. Right. So high corroding rate. High corroding rate mean easy to get rust. Right? So low corroding rate mean hard to get rusty. So and then this one is heat capacity is low, so we need to have the heat capacity high one. So J is the best one. J is the best one. So we are going to answer the question. So first one, more cooling fins, so can trap more wind, so that the water can cool down faster. Right? Larger fan, bigger fan, blow more wind. Right? Can cool down the water faster, and most of the students not there to answer. Like, teacher, this one cool down faster. I write cool down faster. This one also write cool down faster. Can or not? Can. No problem one. Can. Can repeat one. The explanation, the reason can be repeated one. So, low corroding rate, not rust easily. High heat capacity. Please remind that don't write the heat capacity is 5,000. Heat capacity is 5,000. No. Okay. Just write high only. So can absorb more heat and not get hot easily. So answer J. Repeat one more time of your characteristic here. Right. So this one will give you 10 marks. If really come up, then you should be very, very happy. Easy to answer. All right. So we go to the next one. Yeah, if you got any question want to ask me, no. Oh, okay. You start to ask question already. Okay. I'll answer you later. You got question want to ask, you please pause, send it to the group, or send it to me directly. I'll answer you. Not necessary must be hit. Other chapter also can. I will answer your question. Okay, so we go next. Next is this latent heat. Wait, latent heat here. Okay, so 4.3 we go latent heat. Latent heat Q is equal to ml. Q is equal to ml. L is equal to latent heat Q over m. So energy needed for the object to change the physical state. Right? So energy needed for the object to change the physical state without change in the temperature. Right? With the constant temperature also can. Alright? If specific, you need to add in 1 kg. Okay. If they are asking latent heat of fusion and latent heat of vaporization, you need to set the state. Right? So latent heat of fusion is Q is equal to ml. L is equal to Q over m. If they set fusion, so energy needed for 1 kg of solid to change to liquid, or liquid change to solid without change in the temperature. Okay, if vaporization is energy needed for 1 specific 1 kg of substance to change the physical state from liquid to gas or gas to liquid without change in the temperature. Okay. You need to know here if this thing is going up, mean it is heat absorbed. If this thing it is going down, mean the heat is released. Okay. Now latent heat it is at here. This one you go to study lah on your own later if you want in more detail. So I just briefly go through. This one the temperature is increasing. You see, this one is temperature. Temperature is increasing. Increase. Why? Because it absorb heat. Absorb heat for what? To increase the kinetic energy. So here increase temperature increase, kinetic energy increase. Okay. Here this one the temperature not increasing, constant temperature. Why? Right? Why? Because heat is absorbed to weaken the bond between the molecules, not to increase the kinetic energy. Okay. Now this one the same, increase kinetic energy. This one is right to break the bond. This one is weaken the bond. You need to know. This one is weaken the bond. Here it is to break the bond because you want to change to gas already. Weaken the bond, break the bond. And then, how about this one? This one you need to know. This one is to form the bond, right? Here it is to form heat release. To form the bond, right? So this one is to strengthen the bond, right here. You need to know. If you want to go into detail, you study again tonight later. So this one you need to know. Let's say we take one example. For example, this one. Okay, I simply take one example. Now find the energy needed to melt a piece of ice, 200 grams, from -15 to 25. So you draw it out first, right? My way is I like my student to draw it out, -15, right? -15 to 25. So in between, you need to know the melting point, 0. Okay. Now it must be happen in pair. So this one solid, alright, liquid, right? So -15, this one no change, the state no change, the temperature change, right? Temperature from -15 to 0. And then this one change, the physical state from solid to liquid, but the temperature no change. So must be one change, the other one not changing. This one change, this one not changing. This one no change, this one change. Right? We got 3 energy, Q1, Q2, Q3. So this one temperature change, MC theta. Temperature no change, ML. This one temperature change from 0 to 25, MC theta. You substitute it in. M is 0.2, C is 2001 for ice. Read properly. Ice. Right? 2001. And then the change of the temperature -15 to 0. It is increased 15. Don't put negative. Right? If you want to put negative, okay. Right? But you make yourself hard only. 0 minus -15. Right? Final minus initial. So you just put 15 will be okay. Alright. So MC theta, ML, MC theta, you put it in. So L, the unit is joule per kg, no degrees Celsius. Right? This one C got joule per kg per degree Celsius. This is C. Right? This is L. Make sure you know. Alright. So you put it in, answer. Okay. Experiment, I don't want to discuss into detail already. I don't think it is important. Right? This one, application of the latent heat in the daily life. One of the example is cooling system. If not mistaken, it came out in, I forgot. I have compounded already recently. Wait, give me 1 minute. I go and try to find out where it is. Oh, okay. Not here. I have compiled a new one already. Wait, here. Specific latent heat application state paper here. (2004). Now I want to find essay. Wait, let me find the essay. Where it is? SPP. This one SPP 2004. 2004. So it asks in this way, latent heat. So it asks into this way. SPP. 2004 one, the latest one. That's why I think heat it is important. One more, still got one more about the refrigerator one. I forgot which question already. Is it this one? No, not this one. Let me find first. Not this one. Hey, where it is? Refrigerator 4 marks one. I cannot find it. But SBP come out lah. So as you know, SBP one always got one question or two question almost the same as the essay one. So that's why I am predicting the heat in this chapter in SPM. So this one you can go and read. I cannot find where is the question already. But anyhow, a refrigerator is used as a cooling effect from the evaporation during the circulation of the cooling agent. Heat is absorbed from inside the refrigerator and released outside. Now how it is? Now I start from here. I like to start from number 4. If I start from number 1, I find it so hard to explain. So here you are going to put your meat or the chicken. All right, we put the chicken inside here. So the chicken, it is hot right now. You just buy from the market. So it is hot. So so now here, inside here got coolant agent, right? So it is coolant agent. It is in liquid form. Right now it is in liquid form. So this liquid come to here. So it has low heat capacity. So what happened is this one is hot. Hot, then the heat will flow into here. So what happened to this liquid? This liquid will absorb heat. It will absorb heat. Absorb heat. So in the evaporator, the cooling agent will evaporate. So absorb latent heat from the meat, from the chicken inside the refrigerator. So it getting hot. So it can turn to gas, right? Because of the boiling point, it is low. So it can turn to gas. Turn to gas here. So here, this one, it is hot right now. Hot, latent heat, hot, hot, and come to here. You compress it. So the particle right here, it is gas. So you compress it. So it become nearer. So it become liquid again, right? So here, this is the compressor. It is used to compress the gas and then increase the pressure, and then it will turn to liquid. So now here, this one, it is heat is released. Heat is released. If it is not turned to liquid, also can. So here still, if you cannot compress it, still cannot become liquid. So it is okay. So here it is gas, right? So the heat is released from here. Release from here. So this one, when it is released, this one become cold already. Cold gas, right? Cold gas, right? Cold gas. So this one cold, right? And then it become liquid. Now it can be liquid here. It can be not liquid here, right? It can be mixture also can, no problem. So the liquid start to flow to here. So this one here got one valve, right? Valve, expansion valve. This valve make sure the liquid flow through and then cannot flow back. So this one is liquid already. This one is liquid. This one liquid, it absorb heat again. Heat is absorbed. So this process keep on repeating. Repeat. Right, to cool down the what's that called? To cool down the meat in the refrigerator. So evaporation of the sweat also latent heat. The ice, right, cold ice, right, you can also latent heat. Okay, you need to know. All right. A question, then I am not going to go so much already. You just need to know lah. For example, I take one easy one. I take one easy question. For example, this kind of question. Now, x, y, z, w, x, y, z. Okay. At the level y, heat absorb it is. Now, you need to see. This is the lower part. This is the higher part. So, this one is fusion. This is vaporization. You need to identify which one it is. So, this one is latent heat of fusion, not vaporization. Okay. All right. You got question? You can pause it. You can ask me. Okay. Now, this kind of question, I think it is important also, because I am predicting the heat. So, what does it mean by heat? Heat, it is a form of energy. Heat is a form of energy. From very beginning, I already told you here, right? What is heat? Heat, it is a form of content of the energy in the object. Form of energy. Okay. Now, latent heat application. Wait. Where? Some question we didn't do it. Too much already. Heat. This kind of question. Now, for example, they will ask you, explain how the thermal cooker works. Give the two advantage of using thermal cooker. So now you need to know how to answer. All right. So it can reflect the heat and trap the heat inside the inner pot here. The food can be cooked without using the energy outside. So to save energy, the nutrition will not lost. All right. This is the answer scheme's answer. All right. You can just follow. Okay. They will ask you how the cooker work. How the latent heat. So if they don't mention latent heat, so you no need to add in latent heat. Now, this kind of question also So the material for the inner pot, what? The inner pot coated with what? The material used for the outer pot is what? And then the space S. Space S is here. The S. Space S here. Space S here. Now, when you answer, when you choose to do it, so you need to know what is space S. So if vacuum here mean the heat will not escape. Heat, it is going. If this one is vacuum, the heat cannot transfer to here. Cannot. All right. So if it is air, here the heat still can transfer. Right? So the heat will not escape. So vacuum, heat will not escape. So you know it is vacuum already, only these two. So now left this one. So we need to choose material used for the inner pot, aluminum or stainless steel. Inner pot. Right? So inner pot, I'm not sure yet. If I choose aluminum, it is light. Stainless steel, it is heavy. But this one is stainless steel, it will not get rusty. Aluminum will get rusty or not rusty also. Not rust easily, but still can get rust. Okay. Inner layer of the inner pot coated with shiny. Both are shiny paint. So material outer pot. So outer pot, I am very sure it is plastic. So this one is R. Right? Because my house use one, it is plastic. So now I'm choosing R. So you see, the answer is R. Okay, stainless steel, not rust. Shiny paint can reflect the heat. Plastic reduce the heat loss. Vacuum prevent heat loss. Of course, you can write full sentence. Right? This one you write full. Right? And then R, you choose R and then you repeat. Is that okay? So we go to the last part. Last part is Boyle's gas law. Gas law, kinetic theory of gases. So said that the gas in the cross container, number of the molecule must be constant. Mass of the molecule must be constant. Okay. The behavior of the gas depend on the volume, temperature, and pressure. 3. So you need to know when volume. So this one, volume decrease, pressure increase. The volume here, it is small. The volume here, it is big. So chance for this one to hit the wall, it is high. So pressure, it is high. So this one, because of it is far, chance for the particle to hit the wall, it is lesser. So the pressure is lesser. So number of molecule, you got 3, I got 3. So number of molecule is 6. Volume increase, pressure decrease. So this is Boyle's law. Right, this is Boyle's law. Okay, the second one, it is this one. Temperature increase. Temperature increase. So this one, the size, it is the same. Size, it is the same. The number of molecule, it is the same. Alright. So when temperature increase, pressure increase. Okay. Temperature increase, pressure increase. Okay. Number of molecule when it is more. Alright. So now this one will not come out in Boyle's law, Charles law, and pressure and Gay-Lussac law. No. Right. This one can come out in adjective only. Right. Because it is not included in the gas law. Right. The Boyle, Charles, and Gay-Lussac law. So for Boyle's law, Charles law, and Gay-Lussac law must be fixed number of molecule. Fixed number of particle must be fixed. Okay. So the number more, so easy for them to hit the wall. So the pressure will be higher. Okay. Now memorize this one. This one you should memorize it. Okay. Now for fixed number of mass, fixed mass and fixed number of molecule in the container, the pressure is inversely proportional to volume. So the way that I taught you how to memorize PV over T. So this is called Boyle's law. Boyle's law, when you time together these two, it is inversely proportional. And make sure you mention the time, the temperature. Temperature keep constant. Boyle's law, and then this is Charles' law. Charles' law said that V is directly proportional to absolute temperature. Remember to put absolute temperature. Right? Provided the temperature keep constant. Lastly, Gay-Lussac law is P is directly proportional to absolute temperature, provided V is kept constant. Okay? And then when you answer in the adjective, right, you know directly proportional and inversely proportional, how it is look like. I am not going to go into detail of this one. When you see this one constant, right, you see the y-axis here, x-axis I don't care, y-axis is PV over T, then it is a straight line constant. What does that mean? Right? You see PV over T, okay, constant. You see, here, PV over T. Now, this is PV over T. Now, V over T, okay, constant. And then you see this one, if P over T, constant. That's all. Right? And then we try to find out some question, how to answer the question. Now, for example, I got this one, right? Now, so this one is, if you don't know which one, you are okay, PV over T, PV over T, all right? Objective, right? You can put in like that. P, don't have P, leave it, P, V, V, 5. T, 40. But this one is degrees Celsius. Make sure you change it to Kelvin. 40 plus 273. Right? Here, PV over T. P don't have. Right? P don't have. V don't know. T, 85. Plus 273. If it is given in Kelvin, so you don't need to plus. If it is given in degrees Celsius, then you need to plus. Okay, I cancel this one. Alright, so that you got this one over this one. 5 over this one is V over this one. Okay, you will get the answer. Right. I don't care Boyle's law. I don't care Charles' law. I don't care which law. So you can use just one formula in the objective. But in structural question or essay question, please write it properly like this. P1 over T1, P2 over T2. Write it properly. Okay. Okay. I think that's all. That's all for my revision. So I'm going to start to answer your question. Got one student asking me about the transistor. In the afternoon. I mean, 4 o'clock. So I will do a bit of what you asked. This kind of question, make sure you know. Here, this kind of question, go and study how to answer. I read one more time for you. Diagram 11.3 shows a motorcyclist delivering the food. So the food delivery bag in the 11.3, it is non-heat insulator. You are required to modify the food delivery bag in terms of inner and outer layer, mass of the bag, and other aspects. So, answer, right? This one don't have. I give you the answer. This one is Melaka 2022. Okay, Melaka 2022. Melaka. Question number. Wait. MRSM 2022. I'm sorry. MRSM. Not Melaka. What am I doing? MRSM. Kertas 2 jawapan. 11. Question number 11. If not mistaken, 11. Wait. 11. Here. Okay. Now, the mass of the bag, it is low wama. Lighter. Density of the bag, low. These two, only wajib satu only. Right? Just need to have one. Because the question asks about the mass. The question asks about the mass here. Right? Here, the mass of the bag. So you just, if you set density low, you cannot just write both. Right? They will not give you the mark. Okay? Now, safety of the bag, have zip lock. So can trap the heat inside the bag. Size of the bag big, right? Can carry more food. Safety measure, bright color, so can reflect the light easily, so that the driver can see you easily at night. Okay, so this is where you can answer, right? You can write more. Even wrong, they will not minus your mark. They just not give you the mark only. All right, make sure you know. All right. Now I start to answer your question. Right. Mandarin. Never mind. I answer. 老师如果不会做的题目，尤其那4分，可不可以写很多答案，考官去改的，对吗？Yes。how to answer this kind? The question is asking how to answer the 4 mark question, like for example, this question. So now, if you ask me this question like here, it is kind of hard, right? Even me, I told you, I can get sometime 2 mark to 3 mark. Rarely get 4 mark. So not easy to get 4 mark. You don't expect this one to get full. So you try to write more. Okay, where is a hint? All right, normally I'll tell you. For example, um, essay question. For example, this kind of question. Okay, now we don't have the answer, right? We don't have the answer. So this one 4 mark, we don't have the answer. Even me, I tell you, I can get 3 mark only, 2 to 3 mark. So now this question is Sarawak 2021. So now this one I don't care. Now diagram 9.2 shows the land breeze phenomena. Explain how the land breeze phenomena occur. So you see how I answer right here. So now the first mark that I want to write it is land has low heat capacity. Land has low heat capacity than sea water. Alright, I don't know whether got mark or not. Right? We go and see it later. I haven't seen the answer. Right? So the land heat up. This one is cool. Land cool down faster than sea. This one is so negative, huh? So now I don't want. Right? I rewrite. Sea water has high heat capacity. So sea water remain hot, not easily cool down. Sea remain hot. So hot air from the sea surface rising upward. So the 4th mark is the wind from the land. Wind blow from the land. So you write more, right? If you know, so teacher, I know, I know. Here, this one, the pressure getting low, right? Because this one go up already. You go and write it. You know, you go and write it. So I think my mark is enough. Then I don't write. So I'm confident that I don't write. If you not sure, you go and write it. Teacher, this one density low. Okay, so you add in. So now this one is land breeze happen. And I tell you what, I see so many years with different same question but different answer scheme. So some of them they will give this one got mark, that one got mark, this one got mark, that one got. But mostly high heat capacity got mark because this chapter is about heat. So heat capacity sure got mark one. So the density high sometime got mark, sometime no mark. Sorry, density low. Sea surface density low. So sometime got mark, sometime no mark. So I don't write it. Because of this chapter is nothing to do with density. If you got not enough mark, then you put in. You don't have any idea, then you put in. So we try to have a look into the Sarawak 2021. Right? You try to see. Sarawak. Wait. Sarawak. Question number 9. Not this question. Another one. This one. Question number 9. Let me see. No, not this one. I reopen. Sarawak. Question number 9. This question. So question number 9. You see the answer here. Okay. This one is a 4-mark question. Yeah, so hard to see. Wait. Go away. Go to this side. So now heat capacity of land is high. Heat capacity, seawater has high heat capacity. 1 mark, yeah. The temperature drop more slowly. Land. Remain hot can or not? Drop slowly. Same same meaning. Impossible. I can like 100% same as the word of what they gave in the answer scheme. So air above the sea, it is hotter and then rise up. Yeah, air rising up. So cold air from the land move toward the sea. Wind blow from the sea. So teacher, you don't have cold. Yeah, 1, 2, 3. I get 3 marks. I get 3 marks. So cold air from the what? And then I add in land breezes happen. So this is how you're going to get a mark. If you cannot, you get 2 marks also good. Right? 2 marks also good. This question I told you how many marks you should get to get the A already. I told you already. So if you teacher, I write this one density high, the pressure density low, and then pressure low, and then what, no mark. So no choice. You don't know how to write this, you don't know how to write this, then you have to write others. Of course, this one I just told you, then you know lah. So other parts, other chapter, like you haven't learned, you don't know, then how? You have to write more lo. What to do? They will not minus your mark. They will not giving you the mark only. Okay. The second question is about the transistor. Teacher can explain the transistor or not? Afternoon you ask me. So I go to briefly go through the transistor. Transistor. Okay. So I just go transistor only. Transistor got 3 terminal: base terminal, emitter terminal, and collector. Alright, these 3 terminal. So this characteristic you need to know. IB 0, IC 0. IB increase, IC increase more. IB plus IC is also IE. Amplification factor is IC divided IB. So the graph look like this. Okay. The transistor got two functions, right? So one of it is amplifier. When you see the amplifier, right? So you see two-side battery, right? Battery, two-side. So even sometimes this one don't have battery, but it can produce current one. Produce what? Current, induce current one also can. Like what can produce? So like microphone. Microphone, it can produce the current. So it also can be amplifier. So you put a microphone here, so it can produce induced current to generate the current here. When this one IB increase, so IC increase. When you talk to the microphone, slow, so this one will come up with large current. If you don't talk, then no current. Right? IB 0, IC 0. Right? This is how the transistor work. Okay. Now the second function it is right, one side battery only, not two side. One side battery only. So this is just one side. It can be this side, it can be the other side. So calculation you need to know. When you ask me, you don't ask me to go into the calculation. So we just go for how the automatic switch work. So two function. One it is amplifier. The other one will be automatic switch. Automatic switch, one side battery only. So this side or the other side. So this one you need to memorize in that LDR, light dependent resistor. In that resistance is high. Alright, this one you need to memorize. Alright. So when it is at the bottom, resistance is high. Right? When resistance is high, BB, this is best. BB is high. BB is high, then IB is high. Because IB depend on BB, right? So when IB high, then IC will be high. IB will be high, I'm sorry. So IB high, then IC high. IC high. So IC high, the bulb here on. In dark. Right, in dark. In dark, the bulb light up. So when bright, we see bright. Resistance at when bright, resistance is low. Right? Resistance is low. When resistance is low, the best voltage is low. Best voltage is low, IB 0. Or very low, or very low, or 0, or very low, up to you. Right? So IB low, then IC 0. So IC 0, no current flow to here, so the bulb off. The bulb off, will not light up. Okay? Now, how about if I put it into this way? I put into this way, terbalik. Okay. Now, when dark, resistance of the thermistor is not thermistor pula, LDR. Resistance is high. Teacher, just now you said resistance high, VV high. No. So this resistance high, the voltage here high, V high. But base voltage is here. So base voltage here is low. So we are talking about this part, right? Base voltage is low. Base voltage VV low, IB low. IB low, IC low. IC low, so it will not light up. That it will not light up. Not light up. It will not light up. When bright, we are gonna see when bright. When bright, resistance of the LDR is low. Okay? Now, this one you need to memorize, no choice. Resistance is low. So resistance here low, voltage here is low. Voltage here, voltage at the up here it is low. So voltage down there is high. VB is high. VB high, IB high. IB high, IC high. IC high, the thing on. Right? This one on. So when bright, it turn on. When dark, it turn off. I just briefly go through lah. It is how to memorize. Right? So the way that I taught you how to memorize is normal way is if you see teacher Lee, like you see me, so this one hot on. This one LDR at here, dark on. Okay. For example, right, teacher Lee, you see whether this one in objective here you no need to think so much. Teacher Lee. Okay, this one dark cannot on. Alright, bright on. So bright on, dark off. Wait, you see teacher Lee, in objective you memorize this way teacher Lee. So teacher Lee said, oh, this one LDR at here thermistor here hot on, right? LDR here dark on, right? Because the bulb need to be dark then on, right? So if you put the LDR here, oh, dark is not on. Dark, it will not light up. Bright, then light up. I try one more time. Teacher Lee here, right? Teacher here hot on. You put it here cold on. Cold, then on. Hot will not on. Try one more time. How about this one? Right? How about this one? Teacher Lee. LDR, okay, dark on. Dark on. Right? Bright, not on. You memorize, then fast. If not, then you have to IB, IC, IE, and so on. No IE, no IE, just IB and IC. You need to tell IB how, then IC how, then how. Everything. Now, question? Any other question that you want to ask me? Got one question about this one. Just now, afternoon. I answer you already lah, but I still want to answer lah. Alright. Now, the question asked is, what is the working principle of DC motor and DC generator and AC generator? So we don't have the working principle for that. So far I haven't seen any what working principle of DC motor. That is not a working principle lah. So working principle they will ask in transformer, right? Transformer. But I don't answer you that way lah. Transformer. The working principle is electromagnetic induction. For motor, DC motor, you use current and then you turn the motor. Like, what working principle? Why not I ask? Wait, wait, give me 1 minute. I ask ChatGPT. Give me 1 minute. No worry. I ask him. See what will he say. Okay. So see what will he say. DC generator is electromagnetic induction. DC generator, yeah, electromagnetic induction. Yeah. AC generator, it is generator is induction again. Yeah, correct. What I answer you is correct. DC motor is motor effect, electromagnetic, not induction, because it is produced current. So this one, it is electromagnetic force. It produces a force. Alright. This one is induction. This one is induction. Right. Generator, you generate, you need to induce the current. So induction. This one induction. This one is current produce force. But they don't ask in this way lah. They normally ask in the transformer. Any other question before I end the class? If you got question, then I continue to answer you. If not, then I'll let you go early. I know you still want to study. Any other question before I end the class? If you haven't light up, help me to press the like button. Thank you. Help me to press the like button. And then one more thing is, next year I am going to give free tuition in February and March. If you got brother, sister, or friend want to join tuition for free, online tuition, so just let them know my channel. To find my channel, if you subscribe me, you can easily find me. Find my channel, and then it is free. For next year, February and March. Okay. Now, if you got friend or brother, sister want to join, promote them. Right. That's what end my class today. If you no question, then I'll end here. If you got question, you want to PM me later, I will try to answer you lah. I will stay until late night tonight. Okay. All right, I'm gonna stop here. I'll see you. No question. You don't prepare any question to ask me, so I don't answer your question. No, I don't want to answer. Right? Okay, I'll see you. Bye bye. All the best for tomorrow.